Welcome back, folks. Today's May 1st, so that's exciting. It's sunny outside. Getting a fence put in. That's a good day. Today, we got to start looking at our third lesson in systems of equations, talking about the different number of solutions we could possibly have. So, just to start, we'll do a little bit of an investigation. So we'll graph some things, just see what happens. So this is a nice review of those linear equations concepts with slope, y-intercept, that sort of thing. So we're going to change all three of these. So there's three different systems. Remember, a system is going to involve two equations with two variables. So here you can see for A, we've got two different equations, variables of x and y. For B, same thing. And then for C, also the same thing. So what we're going to do for each of them, change them into slope-intercept form, graph them, and just see what happens. Do they cross? Do they not cross? Where do they cross? That sort of stuff. We'll analyze the picture. So if you want to take a couple minutes and start ripping through them, by all means, go ahead. Just pause the video, come back to it when you're done, just to see how you did. But if you want to just follow along, that's fine too. Now, I'm going to, again, number them like I talked about before. I just like to organize them. It's easier for me to talk about equation 1 or equation 2 rather than saying the whole thing. So we'll just number them off 1 and 2. Now the second equation is already in that slope-intercept form. I can see my slope's -3. That's the number in front of x. And my y-intercept is my constant, so it's 1. So I'm just going to write the format of that slope-intercept form underneath. So mx plus b. And you can see that the x's line up. My m is going to be that -3 value. So I need to change the first one because it's not in that format as of right now. So let's use green for that. So equation 1 originally was -2y plus 2x equals -8. And I want it to say y equals. Right now it says -2y plus 2x equals. So I got to get rid of a bunch of stuff here. So let's subtract 2x from both sides, which will give us -2y equals -2x minus 8. So I'm deliberately putting that x term first, so it follows our slope-intercept form. Now I can divide everything by that -2 to get y by itself. Please remember to divide the constant also. It's a pretty common mistake. People will divide on the variables because it looks really nice, they cancel, but many people forget about that constant. Now, in order for this to stay equal, have an equality, you have to make sure you do that to everything. Okay, so y equals -2 over -2 is just x. And this is going to be x plus 4. So there is my first equation represented in slope-intercept form. So what we're going to do is we're going to graph them. Now I'll keep this one in green. I'll do the second equation there in black. So if it's x plus 4 for green one, that means my y-intercept is going to be 4. So there it is at 4. But my slope is actually just 1. So we're going to go up 1 over 1, both in the positive direction, so up and right, to make new points on this line. Now, if you go both in the negative direction, down and left, you're going to end up on the same linear path. Okay, so there's my line. Let go, and it is a line, so it does need arrows. Now, again, you can label that also, so y equals x plus 4. And we got to do the other one as well to compare. So that one was -3, and that's my slope, plus 1 is that y-intercept. So we'll graph that at 1 first. Now my slope says it's -3, so I need to go down 3 units. Instead of rising, we're going to fall, and we're going to go over 1. Okay, 1, 2, 3, over 1. 1, 2, 3, over 1. Now that's enough points because I know they're going to cross. I can go up 3, left 1 also. 1, 2, 3, left 1. So 1, 2, 3, left 1. Now you can see it's not going to line up perfectly like some of the other ones we talked about last week. Doesn't matter, because if I draw my line, I know with 100% certainty that these two lines intersect each other. And somewhere in that red circle, they're going to cross. So here, y equals my -3x plus 1. Now I can't say for certain where that point is exactly. It's going to be a decimal, have a fractional value. Doesn't really matter here. All I know is that they cross. Okay, that's important. Okay, so the slope and y-intercept of both equations. So I had for the first one a slope. How do I number these off again? Yeah. So for the first one, I had a slope of 1 and a y-intercept of 4. For the second equation, we had a slope of -3, y-intercept of 1. Okay, just some of those values. And remember that m was that variable we gave for slope, b was your y-intercept. Now, how many solutions does it have? Whenever it talks about solution in this unit of systems of equations, what it's asking you for is how many points of intersection are there. So these two lines, green and black, they're only going to cross once. And the other one's not going to loop back around and cross again because it won't be linear anymore, okay? So how many solutions it has? Just one. Okay, so there is 1 point of intersection. Okay, so therefore there is one solution. Only one place where the values of x and y are the same on both lines. Okay, now we'll take a look at the second one. Okay, again, we've got to make sure they're in that slope-intercept form. Right now they aren't, so we've got to change them. And again, we'll number them 1, 2. So equation 1 originally is -2x plus y equals 3. That means that y is going to be equal to 2x plus 3. So I added 2x to both sides. For the second one, that is 3y equals 6x minus 3. We're going to divide 3 on everything. So y equals 2x minus 1. Okay. We'll go graph those as well. So for the black ones, my y-intercept is 3. So 1, 2, and 3 is where we're going to start. My slope is 2x, or sorry, my slope is 2. So we're going to go up 2 units, right 1. 1, 2, 1, 1, 2, 1. Okay, there's my line. That's a terrible line, but we can move it over. Oops. And that's not great. Let's fix that. That's a little better. There we go. Okay, fine. So arrows. Now in red, 2x minus 1. So I've got a y-intercept of -1. So I'm just underneath that x-axis. My slope is still 2. So up 2, right 1. Up 2, right 1. Up 2, right 1. There's my line. Okay. This situation looks quite a bit different than the one before. Now, if I'm looking at these ones, we gave these types of lines a name in our previous unit, and we called them parallel. Now, parallel lines means that they never cross, they don't intersect, and every point is actually equal distance from each other on that line. And what I mean by that is if I look at the one I graphed first, okay, my black y-intercept, there's another point in the same horizontal plane as it 2 units away. Now, if I look at another point that I've plotted, the next black one up, there's another red point in that horizontal plane 2 units away. So those two lines are going to be equal distance from each other for infinity, forever, because the arrows, lines mean they extend. Now you can do this in the y direction also. Your two y-intercepts are 1, 2, 3, 4 units apart. The reason why it's 4 this time is because you went to make your new black points by using a slope of 2, but you also did that with the red one. So effectively by going up 2 for both lines, the points are 4 apart, 2 for each line. And you can see that throughout. So here's 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, all the way. Now, if you think about what we just talked about, so for the y direction, if I'm going as a difference of 4, but my x direction as a difference of 2, The rise is 4, the run is 2. When you divide those two numbers, rise and run, you get a value of 2, which is exactly the same as the slope of both lines. Okay, so if those slopes are going to be equal, that tells you something about the number of solutions as well. So we can summarize this and we can say that this is equation 1, this is equation 2. The slope for both lines is the same. It's 2. My first y-intercept was 3, I believe. The next one was -1. But that didn't really matter for us. What mattered was knowing that those slopes were the same. And if those slopes were the same, it gave us a situation that gave us parallel lines. Okay? And if those lines are parallel, they are not ever going to cross. If they don't cross, that means there are no points of intersection. Therefore, there are no solutions. Okay? So these lines never intersect. So therefore, that little symbol with those 3 triangles, therefore, no solution. Okay. So we have a situation now where I could cross and have an answer. I also have a situation where I'll never cross and I won't have an answer. Okay, so it seems like there's only 2, but I happen to have a third case, which we have to talk about as well. So again, 2 lines, just like before for A and B, switch them over into those slope-intercept forms that we know how to graph. So equation 1, 3y equals 2x plus 3. Divide everything by 3. And y equals 2/3 x. So I have a rise of 2, a run of 3, plus 1. Okay, there's one equation. Now equation 2, I'll rewrite it. So 4x equals 6y minus 6. Divide, divide, divide. Wait a sec. I want to get at y equals. Right now it's x equals. So let's add 6 to both sides first. See, sometimes it happens to us too. We don't notice things right away, but eventually it looks weird to us, then we got to fix it. So let's divide 6 actually on everything. That seems better to me. Now 4/6 is a fraction that can be reduced, and your calculator will show you how to do this. Now many people look for that fraction button like you used in junior high, but that's kind of not really existent anymore. So what you could do, just remember a fraction is essentially division. So take your brackets, put in 4 divided by 6, close your bracket, and hit enter. Now your calculator gives you a decimal. Now you could try to think about all the ways to get the same decimal in a lower form, or if you press math, option 1 will actually take whatever answer you have on your screen, try to change it into the lowest terms fraction. So if you hit enter, 2/3 is going to be that fraction. So when you actually divide them, you get 2/3x, which remember, we just talked about parallel and have the same slope, so I do have that here also. But when I divide my 6's, I get +1, that's equal to y. Now compare those 2 equations. My slope's 2/3, my y-intercept is 1 for both of them. These are exactly the same line. So when we go to graph this, I really only need to graph one of them because the other one is going to just overlap it. So we'll do the one in black, y-intercept of 1. Slope is 2/3, so we're going to go up 2 from that point, right 3. So 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. Okay, so there's enough points. I don't really need to worry about the other direction because I know already that my purple line had the exact same equation. So when I graph them, every point kind of just overlaps. So here's the purple line graphed then. And make it easy to see both lines. So in black is one line, the purple dashes indicate that the other line is the exact same right on top. Now we've got to think about this. So originally I had 2 lines that crossed once. I had 2 lines for the second scenario that crossed never. This third one, I actually have 2 lines stacked on top of each other. So no matter what point I pick on the black line, it'll be the same point on the purple line. Well, that's kind of interesting. So my slope for both is 2/3. My y-intercept for both was 1. How many solutions? Now, if we just said that every point on the black line is overlapped by every point on the purple line, I have to have more than one solution, because if those lines overlap, there's multiple places where x and y are the same. Now, if these are lines, those arrows indicate that that happens forever. It just keeps going. Now, if that is the case, we can summarize this by saying there's one line on top of another. Okay, the word we use for that is coincident. Okay, so those lines, basically, if you say coincident, it means that they are the same line. They happen at the same time. Okay, this means that there is an infinite number of solutions. Okay, if those lines extend to infinity for x and y directions, they go on forever, there has to be an infinite number of x's and y's that are the same on both lines. Since the lines are the same, they overlap. So these are my only 3 cases. I could have one answer where those lines cross once. I could have no answers, those lines never cross. Or I could have an infinite number of answers because those lines cross everywhere. Okay, those are the 2 types, or the 3 types, I should say. Those are the only 3. I can't ever have 2, because if I had 2, that would mean one of my lines looped back to cross another one. And I can show you a picture of what that might look like. So on your graphing calculator, this is very helpful for this unit. If you don't have one, don't worry, because of course you can do everything by hand. That's essentially the program of studies, what we're trying to show you. But I'm just trying to show you that you could use that piece of technology if you have it. So let's put in an equation here. Maybe it's x squared, and this one is x. So I'm graphing 2 different lines just to kind of show you. Now, maybe that wasn't the best line. Let's do, instead of x, let's do x plus 3. And we'll make that one bold. So if you scroll all the way to the left, hit enter, you can change the type of line. Okay, so here you go. Here might be an example where you've got 2 points of intersection. Now notice one of those lines curves. That x squared line, we call it a parabola. And that takes care of math 20. So when you see that curved line, or you've got an exponent in one of your variables that's no longer 1, it won't be linear anymore. So this would be still a system of equations, just can't be a system of linear equations because both aren't straight lines. Okay, but I could do it. I could even do something that has 3. So maybe I change this to x cubed, and we see what happens. I don't think that'll do 3 for me. Now I might have to change this back to x. Oops. Delete that key. And you can see what happens. We can even zoom in here. But you could probably tell you might hit more than twice. So let's zoom in right on that origin. Okay. So you've got 1, 2, you can even have a 3rd point of intersection. Now again, not linear equations, still a system. I've got 2 equations, 2 variables, y and x, no longer linear. Okay, so just keep that in mind. It does get a little bit more complicated. The more exponents you place, the more variables you place in, but the concepts are still the same. No matter which ones I'm talking about, as long as those 2 lines, as long as they cross, that point is a solution. It is a point of intersection. I just could have others. Now for Math 10, we only need to be concerned with these 3 cases. I could have 1 answer, no answers, or infinite number of answers. Okay. So all of that is summarized right on the back for you. So if they're intersecting, there's 1 answer, parallel, no answers, coincident, infinite number. They are the same overlapping line. Okay. So when those slopes are different, the lines intersect exactly at 1 point. When the lines are equal, the slopes are equal, sorry, different y-intercepts, that's your parallel scenario. Last bullet there talks about your overlapping. Okay, so here might be a typical question you might see. So determine the number of solutions. This does not say find the solution. This just wants to know how many answers there are. Now in a question like this, really what you're trying to compare is the slope. Okay, so if you know the slopes are different, you've got one answer. If they are the same, you could have no answers. If the y-intercepts are also the same, that means you've got an infinite number of answers. So let's go put this in a form we can see a slope in. So slope-intercept form is going to be your friend. So if I change this first one over, subtract x from both sides, this will say that y equals negative x minus 2. So I've got a slope of negative 1, y-intercept of negative 2. For the one underneath, might be a little bit more work. So we'll change that one to, let's add 2 x's to both sides. So negative 2y equals 2x plus 4. Divide everything by negative 2. And that means that y equals negative x minus 2. Okay. So my lines are identical. Now, if those lines are the same, so therefore, these are coincident lines. There is an infinite number of solutions. Okay. And if you had your calculator, you could check this out also. Just clear those out. Negative x minus 2. And underneath, let's put in negative x minus 2. I'm only going to see one thing. I'm going to zoom out here, put it back to normal. Zoom 6. Great, there's my 2 lines. Now it only looks like there's one. Now if that's the case, if it only looks like there's one, then you know you graphed them correctly because they overlap. They're the same. Now you can check out the table of values also. So second function, up above where it says graph in blue, it says table. You can press that. You should have 2 charts here. Now x is going to be a certain number. The y values are what's going to change. So if you remember from functions, x is going to be your input, the y's are your outputs. Now there's y1 and y2 because we graph 2 distinct lines, 2 different equations. Now when x is 0, the y coordinates on both lines are all the same because they are coincident lines. If that's the case, all of these points, 5, negative 7, that's the same on the other line also. So this table also shows you that every point on one line is the same as every point on another. Okay, so this is why there's infinite number of solutions. This just shows it differently. Okay, for B, if you want to try to go through the next few, you can pause this and try them out, and I'll place the answer in for you. But the questions are very similar. Okay, the equations just change. So if you want to try them out, pause it, come back. I'm just going to start filling in the rest and writing in those answers for you. Okay, so I'm just going to number them off and give you the simplified version. So here's equation 1, equation 2. Number 1 simplifies to y equals 2/3 x plus 5/3. Equation 2 simplifies to y equals negative 2x plus 1. Okay, now if we look at those slopes, they're different. Y-intercepts different. There's going to be one solution. So different slopes. Therefore, one point of intersection. Okay, for C, same idea. So this is 1, this is 2. Number 1 simplifies to being y equals negative 3x minus 1. Number 2, when you rearrange that one, y equals negative 3x minus 6. Same slope, different y-intercept. So same slope, but different y-intercept. Okay, so therefore, these lines are parallel and they have no solutions. These are parallel lines with no solution. Okay, their lines are going to be equal distance apart. And if you tried to graph them, you can see the same thing. So negative 3x minus 1 underneath, negative 3x and minus 6 graph. Hopefully that's on. Yeah, perfect. Okay, and your calculator even shows that they will never cross. Okay. So on the back, determine the number of solutions for linear systems. Same question. So we'll keep doing this the same way. I'll number them off again, give you those y-intercept forms. So 1 simplifies to y equals negative x plus 3. Number 2, when you rearrange it, y equals 2x plus 2. Again, oops, you can't see that right now. There you go. Again, different slopes, one solution. So here, 1 point of intersection. It doesn't ask you to find it. It just wants to know how many there are. Okay. For B, there's 1, there's 2. Number 1 rearranged gets you to y equals negative 2 over 3x minus 5/3. Number 2, y equals negative 2x over 3 minus 5/3. Exactly the same once again. So this one, there's an infinite number of solutions. Okay, everything about those two lines is the same. So this is a coincident case. So these are coincident. Those lines overlap perfectly. And then see the last one here. Same way, number 1, number 2. So line 1 simplifies to y equals x over 2 plus 1/4. And number 2 simplifies to y equals 1 over 2x minus 1/3. Okay. Difference, actually same slope. I've just written them differently for some reason. X over 2 is the same thing as 1 over 2x. So those slopes are the same. Y-intercept's different. So this is going to be a parallel case. So these are parallel lines. Therefore, 0 solutions. Okay, hopefully that went okay for you if you tried it on your own. But many of them are going to be quite similar. So as long as you can find that slope, that'll tell you the most amount of information about the lines. Now, once you get to a scenario that the slopes are the same, then you have to compare the y-intercepts. But if you see that the slopes are different, then you automatically know there's only one answer. Okay, so now we've got to actually create a system. This one's a little different. So we're going to be given this equation, 2x plus 1, negative 2x plus y equals 4. Write another linear equation that will form a linear system with the given number of solutions. Now, it's very difficult to work with this in this format, so I'm going to rearrange it again to slope-intercept form. It makes everything a little bit simpler. So we're going to add 2x's to both sides. So the changed version will say y equals 2x plus 4. Okay, so this is what I have to work with. So now I know my slope's actually positive 2. Some people will look at this and say the slope's negative 2, but they would be incorrect. So now my slope's positive 2, y-intercept's 4. If I need to make another equation to make a linear system with one solution, I can use this one to help. So I know one of my equations has to be this, 2x plus 4. If I need to have exactly one answer, the second line I'm going to create cannot have the same slope. It has to be different. So let's make it 3x plus 4. Slopes are different. They're going to cross, and they will cross exactly on that y-intercept because that point is the same. So you can already see the answer here. And you can check it to make sure you're okay. So 2x plus 4, not 41, and then 3x plus 4. Okay, so they'll cross right on the y-intercept of 4, different slopes. There you go. Okay, so there's a solution, there's a system with one answer. If I want no solutions, 1, 2x plus 4. If I want no solutions, then I need to make sure my second line is parallel to this one. So I need the same slope, but a different y-intercept. Okay, so as long as it's got a slope that's the same, but they start at different points, they won't cross. So let's change this to a 2, this to a 1, and you can see the graph. Slopes are the same, parallel lines this time. Last one, infinite solution case. That's the easiest one because I know if it's an infinite number of solutions, the second line we're going to create, keep it consistent, let's use purple. The second one we're going to create has to be identical. They have to overlap. every point on one has to be the same as the other. Okay, I won't even graph that one because it'll just show me one line. You can already see that line here. Okay, number 2 is very, very similar. Now keep in mind, these aren't the only answers. There's an infinite number of possible solutions that you could give for a question like this, except for this one, it's gotta be the same. But for these, there's an infinite number of choices. Just pick a different slope or pick a different y-intercept. There's so many options. Okay, so for 2, I'm gonna give you a potential answer that you could have. So again, if you wanna pause it and try it out, go ahead. But your responses might be different than mine. So I'm just going to give you one of the possibilities here. So if you rearrange this, add 6x to both sides, this becomes y equals 6x plus 3. That gives us something to go off of. Now I know my slope's 6, y-intercept's 3. So one solution, just a different slope, totally different line. So you could have y equals 2 over 3x minus 1. If there's no solution, make it parallel, but a different y-intercept. That could be y equals 6x plus 6. It was a terrible 6. 6x plus 6, that would work. Different y-intercept. If it is infinite, you can use the exact same equation. Now, here's where you could have a little bit of variation. So if that one was y equals 6x plus 3, you could have negative y equals negative 6x minus 3. Now these are still the same line. Every term just has a negative in front, or the sign has just been switched. So here's 1, here's 2. Now if you remember, this isn't in slope-intercept form yet because that's negative y. Slope-intercept form says y has to be positive. So if you divided everything by a negative, you would actually get the same line. Kind of a little trick that you might see come up, so just be aware that if it's slope-intercept form, it does need to be positive y. Okay, so I hope that one's okay. Just remember that there's only 3 scenarios here: one answer, no answers, or an infinite number of answers. So this lesson essentially wraps up doing things visually with graphs. The next few videos we'll talk about doing things algebraically and a method or 2 that we get to solve these. And then we got to deal with applications of problem solving. So I hope everyone's still doing okay, enjoying the weather, getting outside, taking some breaks when you need it. And until next time, just again, make sure you're asking your teachers for help if you need it, because, well, we get bored too and need people to talk to. So please reach out to us if you need it. Okay, take care of yourselves, guys. See you next time.